A 42% efficient power plant burns coal and generates an average power output of 2.6 megawatts, which I guess makes it small. How many kilograms of coal will it burn in a year? Ooh. Okay, so let's figure out the energy in a year, right? So power is energy divided by time, right? Okay. So that means that the energy that it puts out in a year is equal to power times time. We can do this. So that's 2.6 times 10 to the 6th watts. That's joules per second, right? Then the question is, how many seconds are there in a year, right? That's easy. 365 days per year, right? 24 hours per day. 3,600 seconds per hour. Now let's see what's going on here. Days cancels, seconds cancel, hours cancels, and you'll end up with joules per year, right? Which is exactly what we want. So 2.6, sorry, E6, right, times 365 times 24. Whoops, I just did 25. 24 times 3,600 is 8.19936 times 10 to the 13th joules. Now that's the output, right? I'm sorry, power, energy. And that's the output, right? So the question is, what is the input got to be, right? So the efficiency is energy output over energy input, right? Okay, so that means that the input is the output divided by the efficiency. So that's going to be 8.19936 times 10 to the 13th joules divided by the efficiency, which is 42%, so 0.42. So take the number on my calculator, divide by 0.42. And now I've got 1.95, a bunch of 2's, times 10 to the 14th joules. So that's my energy input, and that's got to come from burning coal. So how many kilograms of coal will it burn? Okay. So every kilogram has 47 megajoules. So there's not really a formula for this, but the energy output of burning something is the mass times the specific energy, right? So therefore the mass is the energy you need divided by the specific energy. So that's going to be this 1.95222 times 10 to the 14th divided by the specific energy, which is 47, times 10 to the 6th, and that's joules per kilogram. So notice it's megajoules, right? So that's 10 to the 6th. Notice if we divide joules by joules per kilogram, we'll end up with kilograms, right? So divided by 47 E6, and I get 4153677.812. 1, 2, 3, 4, 5, 6. 4.15 times 10 to the 6th kilograms. Now, here's the problem: is you can't say mega kilograms, right? Because that's like two different competing, right? It's actually gigagrams, right? Okay. So that's the problem with kilograms being your base unit. Kilo is already a prefix. So people will rebel if you say mega kilograms. So I think we just have to do this. All right.